Okay, so friends, now let's write some real program using this abstract classes and inheritance that we just saw. Let me name my class to be test geometric object, and because I want something to be executed in this class, I will put that to be public static void main string args. Okay. Now let me create the objects of geometric object class first. Geometric object, and I call it geo object 1 as equals to new uh, geometric object, and I call the constructor of geometric object. Oh, it shows me some error now. What should that be? Yeah, cannot instantiate the type geometric object. Now why is that? You can never instantiate the abstract class because the class is incomplete. Even if you instantiate the class, perhaps in the program you'll be using those methods of this class which have no definition to them, and that will create hazards with your Java program, and hence Java gives this error beforehand to warn you that there is some kind of an error because you are using an incomplete class to create an object. And hence, because geometric class is an abstract class, as we all know, we cannot instantiate that class. Okay, but then there should be a question in your mind that if we can actually not instantiate this class, what is the use of putting constructors to this class? Of course, you can omit these constructors without any problem, because when you cannot instantiate this class, the constructor is never going to be called, right? But I will like to keep these constructors as they are, because if you remember, I am uh, I am calling the constructor of geometric object class from a rectangle class over here, super. If you remember, super object will call the superclasses constructor. And for this simple reason, I will like to keep the constructors of my object class as they are. Okay, and I need to change this. So maybe I will call the constructor of say circle class over here, and let me pass the parameter to it to be say 5. Let me create another object of the geometric object class, and this time I'll call the constructor of rectangle class with parameters 5 and 3, let's say. Okay, so that's fine. Rectangle class shows me some error. Let's see what is. Constructor is undefined. Oh, okay. What my constructor is in rectangle class. Oh, okay. So my constructor actually need 4 parameters and I'm passing 2, so that's an error, which is my mistake. I agree. So just let me write one more constructor over here. Public rectangle double width double height. This dot width equals width, and this dot height equals height. Okay, so now I should be getting rid of this error. Yeah, I do. Okay, so now what I do is let me compare the area of these two objects, geometric objects. Okay, so let me do this. I write a comment, compare the areas of these two geometric objects. So and I print that two objects have the same area, and what do I print? I will print GObject1 dot get area. I get the suggestions if I use it. Equals GObject2 dot get area. Dot get area. Okay, something like this. This should be the thing, but I get an error over here because I cannot equate the areas over here at all. This is a syntax error which you know. Perhaps geo, obviously. I think, yeah, okay, it was not a syntax error, it was my typing error. Sorry for that. Okay, so I print this. Now let me display the geometric object. Display geometric object GeoObject1, and but I have not defined this method anywhere, which I will do it right now. Okay, so let me define that method. Public display geometric object, and I pass the geometric object to it. G, let's say, or maybe more descriptive object. Okay, and what do I do? System.out.println. Let me print the area like this. The area is object dot get area. I print system dot. Okay, and I print system.out.println the perimeter is object dot get perimeter. But now you know I cannot use the method like this. I cannot call some method without actually instantiating that, and if I need to do it, I call it a static method. Okay, I do this. Okay, and I need to define the return type, which I will put to be white. Okay, I think I should be fine, and let me try and run this. Okay. Yeah, and here I get a value. Are two objects, the two objects have same area? No, they don't. The area for GeoObject1 is this, the perimeter is this, area is this and this. And I hope the answers are correct because I am not going into the math of it. Okay, so yeah, that is fine. So this is a simple program that I wrote. Okay, a couple of more concerns that we should be seeing before we close our discussion on abstract classes. Actually, there are a couple of them. Okay, can the subclass be abstract? Okay, we did learn, right, that if the superclass is abstract, then subclass needs to implement the abstract methods of the superclass compulsorily, or you need the subclass to be abstract. But can it be the other way around? So subclass is abstract, but superclass is not. Now the non-abstract classes are called concrete classes in Java. So non-abstract and concrete are the same. I may be using both the terms here and there. So can the superclass be concrete but the subclass be abstract? Yes, and why not? I can show you an example right over here. You see, Geometric object is an abstract class, but if you remember from inheritance, this is equivalent to I write over here extends object, which is a Java class, right? The Java library class object. Object is a concrete class. Now you need to believe me for that, because we are not compulsorily writing any method of the object class if we don't want to. So it extends the object class. So the subclass, which is geometric object, is abstract, while the superclass object is not abstract, it's concrete. So you can do that very much. Okay. One more thing. A subclass can override a method from its superclass and define it abstract. For example, I have a toString method over here which I did override over here. Let me write it all over again. What was the return type? White, I guess. Public string toString. Okay, public string toString. I don't want to write that, and so I put this to be abstract. So basically I am overriding the method from the superclass and I'm calling it abstract, but to do that I need to make my class also abstract like this, and it should be fine. You can do that, no problem. But then I need to make sure that whichever new class which extends circle class should write the definition for toString method compulsorily. Okay, so that is fine. One more thing I'd like to show you. Let me revert back the changes that I did. I'll remove this. I'll also remove the abstract keyword over here because the class is not abstract, and let me keep it concrete. Okay, so this program is fine now. Suppose I can write things like this too. Geometric object C is equals to new circle 2, right? This we know. Okay, so this is fine. Now I can also create an array of this. How do I do that? As we create a simple array. Okay, new geometric object size 10. If you want to do this, okay, small mistake, like this. Okay, I can do this, but now this will necessarily be the null elements in the array. Okay, so now this is syntactically correct, no problem with that, but it will be all the elements of this array are null. I just forgot one more slash over here. Okay, so this is a small thing I wanted you to remember, just you can know, because I cannot use a new operator with geometric object, right? You know that I cannot create an objects of an abstract class. So that's it. In the next part of this lecture we will go through a quick recap of what I told you as a part of the program. Let me list them explicitly. Okay, and that is what we'll be doing in the next part of this lecture. Thank you.